Hello everyone, I am Rohan Agarwal and I will be telling you about closure properties for context-free languages. Firstly, what is a context-free language? A context-free language, commonly known as CFL, are the languages that are accepted by push-down automata but not by finite automata. CFLs can be generated by context-free grammar, which is of the form this, where A belongs to N and P belongs to T union N whole complement. and n is non-terminal, and where n is non-terminal and t is a terminal. Now I am going to tell you about its closure properties. CFLs are closed under union, clean closure, and concatenation, whereas non-closure properties are intersection and complementation. Now I am going to explain each property with questions in the end. Now, first property we have is the union property. If L1 and L2 are two context-free languages, their union L3, L1 union L2 will also be a context-free language. For example, L1 equal to a raised to power n, b raised to power n, c raised to power m, where m is greater than or equal to 0, n greater than or equal to 0, and L2 equal to a raised to power n, b raised to power m, c raised to power m, where n greater than or equal to 0, m greater than or equal to 0, and now L3 equal to L1 union L2, where L3 equal to a raised to power n, b raised to power n, c raised to power m, union a raised to power n, b raised to power m, c raised to power m, where n is greater than or equal to 0 and m is also greater than or equal to 0, is also a context-free language. Let's say L1 says number of A's should be equal to number of B's, and L2 says number of B's should be equal to number of C's. Their union L3 says either of the two conditions to be true. So it is also a context-free language. So CFL are closed under union. Now second property we have is the concatenation. If L1 and if L2 are two context-free languages, their concatenation L3 equal to L1 dot L2 will also be a context-free language. For example, L1 equal to a raised to power n, b raised to power n, where n is greater than or equal to 0, and L2 equal to a raised to power m, c raised to power m, where m is greater than or equal to 0. So L3 would be L1 dot L2, which is equal to a raised to power n, b raised to power n, c raised to power m, d raised to power m, where m and n are both greater than or equal to 0. It is also a context-free language because L1 says number of A's should be equal to number of B's, and L2 says number of C's should be equal to number of D's. Their concatenation L3 says first number of A's should be equal to number of B's, then number of C's should be equal to number of D's. So we can create a PDA which first put first push for A's, pop for B's, push for C's, and then pops for D's. So it is also accepted by pushdown automata and hence a context-free language. Note that it is so CFL are closed under concatenation. Now third property we have is the clean closure. Clean closure is the simple one. If L1 is the context-free language, is clean closure L1 star uh, will also be a context-free language. For example, L1 equal to a raised to power n, b raised to power n, where n is greater than or equal to 0. So L1 star would be a raised to power n, b raised to power n whole star, where n is greater than or equal to 0, is a context-free language. Now we will be discussing two non-closure properties, that is intersection and complementation. If L1 and if L2 are two context-free languages, their intersection L3, L1 intersection L2 need not be context-free language because Let us say for the example L1 equal to a raised to power n, b raised to power n, c raised to power m, where n and m are greater than or equal to 0, and L2 equal to a raised to power m, b raised to power n, c raised to power n, where n and m are also greater than or equal to 0. So L3 equal to L1 intersection L2, where a raised to power n, b raised to power n, and c raised to power n are considered, where n is greater than or equal to 0, need not to be a context-free language, because L1 says number of A's should be equal to number of B's, L2 says number of B's should be equal to number of C's, so their intersection L3 says both conditions need to be true, but pushdown automata can compare only two. So it cannot be accepted by pushdown automata, hence not a context-free language. Similarly, complementation of context-free languages, language L1, which is uh, epsilon star minus L1, need not to be a context-free language. Note that CFL are not closed under intersection and complementation. Now we will discuss the questions based on closure properties of CFL. Let us say consider the language L1, L2, L3 as given below. L1 equal to a raised to power m, b raised to power n, m comma n greater than equal to 0. Similarly, L2 equal to a raised to power n, b raised to power n, n greater than equal to 0, and L3 equal to a raised to power n, b raised to power n, c raised to power n, n greater than equal to 0. Now, there are some statements given. We need to tell which is not true. So, as we can say that, and we can see that option A says PDA can be used to recognize L1 and L2. L1 contains all strings number of followed by any number of B, so it can be accepted by PDA. L2 contains strings with n number of A's followed by n number of B's, so it can also be accepted by PDA. So option A is correct. Now option B. Option B says that L1 is regular. It is true, as regular expression for L1 is A raised to power A star B star. Now option C. Option C says L1 and L2 are context free. L3 language L3 languages contains all strings with n number of A's followed by n number of B's followed by n number of C's, but can be accepted by PDA. So option C is not correct. Similarly, so also option D is correct, as Turing machine can be used to recognize all three languages. Option 3 was that Turing machine can be recognized by all three languages. So yeah, it is correct. Now question 2. In question 2, the language L equal to 0 raised to power I, 1 2 raised to power I, and where I is greater than equal to 0. Over the alphabet 0 comma 1 comma 2 is, we have to tell it is not recursive, is recursive and deterministic CFL and other options. So in above language, so the above language is deterministic CFL. As for zeros, we push 0 on stack, and for 2's we pop corresponding zeros. As there is no ambiguity which moves to take its deterministic, so option B is correct. As CFL is a subset of recursive, it is recursive as well. Oh, okay, now for question 3, which of the following grammars generate the language L equal to a raised to power I, b raised to power j, where I is not equal to j? So, yeah. So the best way to solve these type of questions is to eliminate options which do not satisfy the conditions. Like the conditions for L1 is number of A's and number of B's should be unequal. In option B, S S equal S in option B, it generates a string with equal A's and B's. So option B is incorrect, as we have the condition that in language L, number of A's should not equal the number of B's. In option C, S belongs to AC belongs to C belongs to epsilon. In epsilon, A's and B's are equal as it is 0. So it is also not a correct option. Now in option A, S will be replaced by either AC or CB. C will either generate number of A's more than number of B's by 1 or number of B's more than number of A's by 1. But more A or more B can be compensated by B belongs to B small b capital B. So and epsilon or A belongs to small a capital A and epsilon respectively. So it may give strings which is with equal number of A's and B's. So it is also not a correct option. Similarly, in option D, so in D, S will be replaced by either AC or CB. C will always generate equal number of A's and B's. If we replace S by AC, A will add at least one extra A, and if we replace S by CB, B will add at least one extra B. So this gamma will never generate an equal number of A's and B's, which satisfies the condition. So option D is correct. So we can see that we have discussed the questions for CFL, closure properties for CFL. I hope you have understood all the questions and all the properties. Thank you.